Hello friends, welcome back to my channel Excellent Protein X. In this tutorial video, I'll be focusing on Swiss model, how to build homology model. I already made one video on Swiss model, but that was very brief. But in this tutorial video, I'll be discussing more elaborately about this Swiss model, and there are also some factors I'll be mentioned here, and that factors you need to be keep in your mind before building this kind of model. So let's move on to the tutorial part. So first I need to copy one structure from the UniProt. So I'll go to the UniProt database first. And there are some factors that are really very important, and specifically I'll mention and I will point out those factors here. So first, for example, I would like to search one protein, that is perforin. And in this database also you will get a lot of information about any specific proteins, even structure, and also different organisms which these proteins belongs to. But basically I want to say something in starting of this modeling. So first I want to say that why you will choose this kind of homology model, why you would build this Swiss model to build your any protein structure. There are two or three reasons. The first, if you have any 3D structure of the protein and you might miss some part of the protein that is very important for docking, so in that case also you have to make a new model for that, because if it is like if the part of the structure is missing from the entire protein structure, then it might influence your docking or any useful tools. So for that is one reason. And also in the second, if there are in most of the cases you find your 3D structure from UniProt or PDB database, but in some cases if you cannot find your any desired structure, so in that case you have to build your 3D structure by using the Swiss model. So that is the second reason. And another reason also there, if your protein is very much long structure, if you have the very big structure, if you have any this kind of proteins, and you no need anymore this kind of big structure, the entire structure for your homology modeling or for docking purposes, so you need only very specific or part of the structure. So you should focus on that part of the structure, so you can use that linear partial structure to construct your homology model by using Swiss model. So this is the number 3 reason. So there are 3 different reasons that is for very important to build up the Swiss model. So let's move on to the main part. So the perforin structure I already got here. So first you see there are different organisms. So I would like to go for the Homo sapiens. I'll go for 3 different structure. Okay, this is Homo sapiens. And lot of information inside the whole package you'll get here. and the structure also available. So for these proteins is the 3D structure already available, the crystal structure, so you no need to build up any 3D structure by using Swiss model for these proteins. Okay, so if I go to the another one, for example the mouse one, let's see that structure is available or not. This is the mouse one. Also the structure available here. So also you no need to build up the structure, right? So okay, let's move on to the another one. Maybe the zip, this one. So here you see the structure not available. So the other previous two in two cases that structure is available, but here structure is not available. So for this one, so I can choose for build up a model. So here you see here the sequence. This is the sequence of the amino acids, and if you have to click the first sequence, and then you would get this kind of structure. You have to copy it, and then you should go directly to the Swiss model server website. Swiss model, right? So this is the Swiss model server, and this is the main home page. So you have to click, you have to paste your copied sequence here, and also add hetero target, and there is one options, but for this one I don't need to add any hetero target, so I'll directly go for the search for templates. So there are two options, build model and search for templates. You should not go to the build model first, because you have to search template and you have to check it out that which kind of structures are more family, more like stable and more identical. So that kind of structure we have to choose. So before that, so you have to hit this one, the search for templates. So it takes also a while, because it also depends on your network speed and also the length of your structure. If the structure is very big, so it might take a longer time. And also there is one link available here. You see the red marked, and you can use this link if you have any problem, if you have to interrupt any this modeling in this time. So you can remember this one, and you can by using this link you can get back here. So it's already running. You see here the current status also here is showing, is running, and also there are all parameters is checking and searching the templates. So it takes a longer time. Yeah, here we go, is already got. So see here the structure, how many structures is found. The 32 templates is already found by this server, right? So right now here I will show you the most important part, that how you choose out of this 32 structure which one is the best suitable structure for your structure. So here you see there are some kind of score. So this is the GMQE score, and also this one score is not available, and identity. So first we have to check the identity. So identity here is the 68%, 69%, and also the coverage. So you have to choose first the coverage and identity first. So you see here, if you take your cursor here, so initially it's showing coverage 0.96, and this is 0.96 as well, but here you see the coverage is very low, 0.23. Here is 0.96 as well. So so based of this four structure, I should go to the this one, because this is the GMQE score, and this GMQE score is for the expected accuracy. So it means that higher accuracy rate here. So also the identity is 68%. So if it is more than 50%, that is very good structure. So I should go for this one. And also the method is X-ray. Okay, so I'll go for this one. So click first build model, and after hitting the build model, also you will get some other parameters. You have to check it out. And you see here there are a lot of informations, and you have to extend this one, and there are three different, but first this one, and then you see here the GMQ score, that is 0.81, that is fine, no problem, and coverage is okay, and Q mean is the Z score, and this is the score indicates the quality of your structure. If it is less than 1, that is very stable. Normally it is the score, it is should be 0 to 1 in this range. If it is in this range, then your structure is the quality of your structure is very good. So for this one, for the dark one is is less than 1 Z score, and this one is less than 2 but less than 1. Okay, all right, so this is okay, but it's not very perfect, but although I can use this structure because this is in between in 0 to 1, so I can choose this one. All right, and also so you have to keep in mind the coverage, identity, and GMQ score, and also Q mean score. And also I will show another important parameter, that is the structure assessment, and that is basically you have to check the Ramachandran plots. So here you see Ramachandran plots are very important to check or select any structure, because this is for all of these spots. Yeah, so all of these spots you see here, and each of these spots represent each of the amino acid. All right, so and this kind of graph, it represents the rotation of this kind of the amino acid. So all of the amino acids is rotatable for in the 360 degree, that is the torsion angle, and they have the contribution for the stability of the structure. So each of the amino acid, it has the contribution for the stability of the structure, but not all of the amino acid should not rotate for the 360 degree, that is not favorable. And here is showing, if you scroll down further, you see here the Ramachandran outliers and 0.57%, and Ramachandran favored 95%. So that means that your structure is very stable, no doubt. And here you find that also another important factor, that here the bad angles, so 50 bad angles. So out of 5757 angles, in total 5757 angles, so out of that 50 angles are bad. So it means that's also okay, no problem. That is 95%, that is very high percentage of your structure percentage, that is very fine. So so you can use this one. So little bit you can check it also when you select your structure. So that's it, guys. So I hope this video will be helpful.